Hello, calculus students and seekers of truths. We end our study, at least for this particular problem, of velocity, position, displacement, and the definite integral with one more question. So let's recap. This function here is v of t. At t equals 7 hours, the car's position is 225 miles from its starting point. So this is really, there's no way for us to figure this answer out just by looking at the graph. This is external information here that at 7 hours, the car's position is 225 miles from its starting point, or for some point of reference. Right? There's no way you can figure this out just from looking at the graph. It's just external information. On the side here, I'm going to define some new functions and variables. So I'm going to say S of t is the position of the car with respect to abbreviated WRT, some starting point. All right, and so what this is telling us here is that S of 7 is equal to 225. And what we're trying to do is find the position at S of 10. So we know that S of 7 is equal to 225. What is S of 10? All right, now from the problem that we're given, we can actually, before we engage in this particular problem, let's just talk about how do we even find this, even if before we even have a graph, right? So the position at 10, right, the position of the car at t at 10 is equal to the position at t equals 7, right, plus the displacement between 7 and 10 hours. So how far you are, or where you are located, is really your displacement between two time intervals plus your position at the first time interval. So the car is at the position of 225. We want to know where is it when t equals 10. So in other words, we want to know what happened between 7 hours and 10 hours. If we know what happened between 7 hours and 10 hours, we could use that with the 225 miles here to figure out where is it when the time is 10 hours. So this is kind of the long, complicated way to say it. We can compactly represent it in the following. We can say that the position when the car is at t equals 10 hours is equal to the position when the car at time t equals 7, right, plus the displacement between 7 and 10. So we can represent this as the following. Remember that the displacement is the definite integral from 7 to 10 of the velocity function. Right? So when I say what happens between 7 and 10, I'm really referring to this definite integral here. Between 7 and 10, something changes in the car's position, namely there's some displacement, and if we take that displacement and add it to the position at time equals 7 hours, then we have our answers. So now all that's left for us to do is to enter in some values. The location of the car, or the position of the car when S is equal to 7 is 225. The displacement here, we can represent this with the definite integral. So that's the area from, not from there, between 7 and 10. So this area right here that I am shading in, right, this region right here, that's the whatever this area is, that's the displacement between 7 and 10. And we know that this is going to be a negative number, right? So because this area is beneath the x-axis, so it's going to be plus a negative, or I'm just going to change this to being minus. All right, now let's look at this area. There's a couple ways. This is kind of a combination of a trapezoid and a rectangle. So there's a couple ways we can do this. We can look at this block right here, right? So this is an area of 3, and this right here is looks like that's negative 40, and so that's going to be, or 40 rather, right? But the final answer is going to be a negative. So 3 times 40, and then you have 2 more boxes here. So this is 2 times 20 plus a half right here of a box, so this region right here. So that is 1/2 times 20, or 10. Okay, so putting all this together, we get negative 120 plus 40 plus 10. So that's negative 170. 120 plus 40 is 160, negative 170. Okay. Now, let's think about what this number means. Negative 170. Remember, the units here are actually in miles. Okay, and we have a negative number. So this does not represent distance per se. It represents position. Okay, so at t equals 10 hours, the car is, oh, excuse me, I almost messed this up. So close to messing this up. I messed it up because I forgot to include the 225. So this is 225 minus 170. So that is a total of 55. Excuse me, this is 55 miles. Okay, and again, this is still position. So this car is 55 miles from its starting point. Okay, this does not mean that it traveled 55 miles altogether. It's not the distance that's on the car, right? The odometer of the car changes, and it's always going upwards, but this is just with respect to some reference point. The car traveled 225 miles, was 225 miles away from its starting point at time t equals 7, and then it actually went backwards 170 miles during that time interval. So now its position is at 55 miles. So there you have it. Hopefully this helps to connect some of the ideas that we've been discussing about the definite integral, the negative of an area, and in particular how it applies to the context of velocity, position, and displacement. As always, ask for help if you need clarification. Thank you for watching, and have a wonderful day.